Customer sent in a dual gate opener board that's blowing fuses. We have 24 volts DC coming into the AC supply. We don't have an AC supply here. This is going to work just fine. Let's figure out how we can simulate our motors. We know there's two options for motors for this gate. We don't know what the customer has. There's around a 40 watt version and around a 70 watt version. We're using what we have in the shop here. We have two 100 watt resistors, 16 ohms apiece. Let's see if we can use these. To calculate resistors in parallel, the formula is 1 over RT equals 1 over R1 plus 1 over R2 for as many resistors you have in your parallel circuit. .72 watts. So if we use one of these 16 ohm resistors, it's going to be a 36 watt draw on the circuit. If we add the second resistor in parallel with the first resistor, the equivalent resistance of this circuit here is going to be 8 ohms. So this can be thought of as an 8 ohm load. Once we connect it, we're going to be drawing 72 watts. So this satisfies our requirement for our two test cases, where if their motors are 36 watts, that'll satisfy that test case with one resistor. If they are using the bigger motors, which draw around 72 watts, having these in parallel will satisfy that test case. Let's test the current when we're using one resistor. Now we're going to measure the current flowing from the board through the meter into this 116 ohm resistor back into the board in 3, 2. There we go. So about 0.7 amps, 700 milliamps. We connected the other resistor in parallel now, so we're going to be testing the current flow from the board into the meter through both of these resistors back into the board. So we should see roughly double the current. Let's check it in 3, 2. Three, two. So it was 0.7, so 7, 7, 14, 1.4 roughly. Good, looks good. So the circuit itself seems to be working flawlessly. Nothing is heating up here on the board. Nothing is even getting remotely warm. Obviously no smoke. And we're absolutely exceeding that 1 amp fuse here. So we have a wire shorted across that fuse. I don't believe 1 amp is a correct fuse size for this board. I'll do some more research and we'll get this figured out. But in the meantime, I hope this helped. Anybody else trying to sort of troubleshoot an unknown board or supply to figure out maybe correct wattages or testing the current supply coming out of board. Any questions, you can leave it in the comments, or you can contact us at rudolphrepairs@gmail.com. In the meantime, we're going to keep cracking on this board for the customer. It seems to me that the issue is that it's incorrect fuse size. We're going to check the components on the board itself to make sure that a larger fuse will be safe. First thing, we want it to be safe for the customer. But we're going to kind of do some investigation and get some clues on the board check the specs of these transistors, and obviously the bridge is fine. That's a monster bridge. Some of these driver transistors here, and we're going to figure out what the fuse value probably should be based on all this other investigative work that we're going to do on this board here. Until next time, rudolphrepairs@gmail.com, www.rudolphrepairs.com. See you next time.